All right, let's jump right in. We're going to tackle one of the biggest puzzles in artificial intelligence today. How on earth does an AI actually remember things? We're about to uncover a secret blueprint that connects almost every major AI model out there in a way you've probably never seen before.
So, you ever wonder about that? How a chatbot can just pull up some little detail you mentioned like 10 minutes ago in a long conversation. It feels like magic, right? But it's not. Behind the curtain, it's this huge engineering puzzle. How do you get an AI to keep track of a whole conversation, from the very first word to the very last, without completely losing the plot?
Well, here's the problem. The AI world is kind of like a zoo, a really confusing one. You've got these incredible models, like the Transformer. They're the big lions of the zoo. But give them a long conversation, and they start to get really slow, and they eat up a ton of memory. So, to fix that, you've got this explosion of other models, linear RNNs, state space models, the whole shebang. And every single one has its own weird, complicated way of remembering stuff. Honestly, it's chaos.
So how do you sort out all that chaos? Well, the researchers behind this amazing breakthrough look for inspiration in, the best memory system on the planet, the one that's sitting right between your ears. They zoomed in on this one specific thing our brains do all the time. It's called attentional bias, and it's simpler than it sounds. Just think about it. When you're listening to me right now, you're not memorizing every single word, right? Of course not. Your brain is automatically picking out what's important, the key ideas. You're naturally biased towards what matters most. That's all it is.
And this wasn't just some fluffy idea. No, the researchers literally wrote it down as their starting point. They asked a really simple but powerful question. What if we could build an AI's memory to work the same way? To be built from the ground up on this idea of prioritizing information, just like our brains.
And that single question, it didn't just lead to, another new model to throw into the zoo. No way. It led them to something much bigger, a universal blueprint, a framework for understanding all AI memory. And they gave it a name, Miras. And this is it. This diagram you're seeing, this is the core of everything we're talking about today. This is the Miras Framework. And it's this beautifully simple way to finally make sense of that whole messy zoo of models. The big idea here is that pretty much any advanced AI memory system can be broken down into just 4 key parts.
Okay, so let's walk through these 4 pillars. First up, you've got the memory architecture. Just think of that as the storage space, right? The brain's hard drive. Second, the attentional bias. We just talked about this. This is the rule for what actually gets saved. Super important. Third is the retention gate. This is a cool one. It's like your brain deciding which memories to keep right at the front of your mind, ready to go, and which ones to file away for later. It's not about forgetting. It's about making the important stuff easy to grab. And finally, number 4, the memory algorithm. That's just the learning process itself, how the AI takes new info and updates what it already knows.
Oh, and the name, Miras? It's not random. It's a really cool detail. It actually means legacy in a bunch of languages, and that's exactly what the researchers hope it will be. A lasting legacy, a blueprint to guide how we build AI for years to come.
All right, so we've got this blueprint. That's great, but here's where it gets really powerful. It's not just about building new stuff. It's about understanding everything that's already out there. It's like finding the Rosetta Stone for all these different AI models. And this is the aha moment. This is the big reveal. When you use Miras as a lens to look at that whole zoo of models that are supposed to be competing with each other, you find something insane. Deep down, almost all of them, from the original Transformer all the way to new hotness like Mamba, they're using the same basic kinds of attentional bias. It turns out they're all just trying to solve the same math problem, just in slightly different ways.
And this table just lays it all out perfectly. Look at this. You've got these famous models built years apart, and they seem totally different on the surface, right? But when you map them onto the Miras framework, bam, the secret connections pop right out. Look, Transformer from 2017 and DeltaNet, both using something called L2 regression for their bias. Then you've got RetNet and Mamba, much newer, both using dot product similarity. See? They're all just different flavors of the same core idea. The blueprint totally works.
Okay, so the blueprint can explain the past. That's cool. But the real test is, can it help us build a better future? To prove it, the researchers basically put their money where their mouth is. They used Miras to design 3 completely new models from scratch.
So let's meet the new kids on the block, Moneta, Yaad, and Memora. Each one was built by making slightly different choices inside that Miras blueprint. Moneta is the adaptable one. It uses a really flexible way to check for errors. Yaad? You can think of Yaad as having a coping mechanism. It's really good at handling curveballs, surprising info that would throw other models off. And then there's Memora, the historian. It has a super sophisticated way of holding on to old knowledge so it doesn't get lost. So, the big question, do they actually work? Let's look at the data. First up, efficiency. This graph is all about performance versus how much computing power you need. For this chart, lower is better. And just look where our new models are. Moneta, Yaad, and Memora. They are consistently crushing the older models, getting way better results while using a lot less energy.
All right, next test, the long conversation. This is the killer for most models. It's where they just fall apart. You can see it on the graph. As the amount of text gets longer, their performance just tanks. But look at the Miras models. While everyone else is faltering, Moneta, Yaad, and Memora are just cruising along, holding that high performance. It proves their memory is just way more robust.
And if you need one knockout number, here it is. They did a needle-in-a-haystack test. You know, burying one tiny fact in a mountain of text and asking the AI to find it. Well, Moneta scored a jaw-dropping 93.5% accuracy. Let me be clear, that isn't just a little better. That's a total game changer for an AI's ability to find exactly what you're looking for.
Okay, so let's pull back for a second. What's the big picture here? What does all this mean for the future of AI?
Look, at the end of the day, Miras is so much more than just these 3 new models. It's a common language. It's a unified blueprint that finally lets researchers understand how all these different models are connected, compare them in a way that actually makes sense, and, this is the most important part, build the next generation of AI in a smart, systematic way. It takes that chaotic zoo and turns it into a perfectly organized library.
It's pretty amazing when you think about it. This whole thing started just by looking at our own brains. By teaching an AI to remember a little more like we do, to focus on what's important, we've unlocked a completely new level of performance. Which leaves us with a really big question, right? We've taught AI to remember like us. So, what should we teach it to learn next?